Hello again, Year 7, and welcome back to Learning with Mrs. Cowlin. Here is your task for the week beginning the 20th of April. This is a plastics challenge. It has some chemistry in, it has some biology in, and it has hopefully lots of creativity from you in. I'm really looking forward to getting some great work from this and going beyond R2s hopefully for the outcomes. Now, this lesson is going to require that you'll use your pen, paper, books, the plastics you collected last week, and a ruler. If you need to get any of those, pause it while you go and get yourselves organised. First task is to do now. You've got two cells already labelled to show you which one is plant, which one is animal cell, possibly a slightly different diagram from before. That's deliberate because there are lots of different ways of drawing these things. There are 6 labels to put on here. You can just do the labels, or you can draw the cells, which is always good practice, and then label them. Remember, you can pause the video while you do this, and please also remember, drawings need to be done in pencil. And here are the answers. Now, the jelly-like substance inside all cells is cytoplasm, spelt with a C. You've got your spellings here to help you make sure you're still remembering them, getting them right. And then you have a nucleus shown in both cells, plant cell and animal cell. That is the largest organelle in the animal cell, not the largest in the plant cell. The plant cell also has a big vacuole in the middle, a bit like a vacuum. It looks like a space, but it does actually contain water. It is not completely empty, so it's not a vacuum. And both of them have a cell membrane. The cell membrane is around the outside of the animal cell. It's the inside of 2 layers. The inner of 2 layers on the plant cell. Plant cells have a cell membrane. They also have a cell wall, remember, that helps to make them rigid, gives them structure, because they don't have a skeleton like animals. Now, there are 3 objectives today. We are going to be sorting and classifying plastics using their properties. A property is what a material looks like or how it behaves. We are going to understand the impact of plastics on the environment, and we're going to design an idea to reuse plastics. We're going to see that plastics are hard to recycle. Some can be recycled, but actually if we can reuse them first, then that's even better because it reduces the amount of energy needed to recycle. Now, you have got vocabulary check here. You've got 3 words that you need to understand the meaning of: transparent, translucent, and opaque. They're very similar. They can feel very similar, but they're not. Okay, the 2 that start with transparent, translucent, have the same root because they both allow light to pass through them. Okay, trans as in transport or transmit. But if something is transparent, the objects behind it can be clearly seen. For example, looking out of an ordinary window, you want to be able to clearly see what's outside it, especially if, say, it's the window of a car and you're driving. If something is translucent, the light will pass through, but you cannot see the items behind it clearly. For example, you may have frosted glass on the window of a downstairs toilet for fairly obvious reasons. If something is opaque, it does not allow light to pass through it at all. Now, I would suggest if you're not sure about these words already, you write them down in your book so you remember them, because you are going to need them for this activity we have got coming up. Reminder on here of what you're going to need with the practical activity. You will need your set of plastics, you'll need paper, pencil, scissors, and either a bowl of water or a sink. Before we start our activity, we are going to draw a table. Okay, this one has got space for 4 samples. You can add 5, 6, whatever you've got, but do make sure the things that you are testing, you have got permission to test and that you are safe with it. Now, first of all, you're going to have a look to see if there's a symbol moulded on the plastic. It will probably be a triangle type of symbol with a number on. There is a slide after this that will help you with those later on. That is what you will use to fill in the full name of the plastic in the 2nd column. The 3rd column you will complete by looking at it. There comes the vocabulary from the previous slide: translucent, transparent or opaque. You have to decide for each of those. Then you have to try bending it. Is it flexible? That means it will bend easily. Is it stiff? That means it is resistant. Some plastics are designed to hold their shape. If you have, for example, a ride on car or scooter for a young child, you don't actually want it to bend when they sit on it for fairly obvious reasons. Fifth column, what happens if you scratch it? Does it, if you get a pair of scissors and you try to make a mark on it, is it able to do that? Is it resistant? Can you cut it carefully with scissors, making sure that they are scissors you have permission to use, and making sure it's plastic you are allowed to cut it? Yeah. If it cuts, does it cut cleanly, or are there white marks along the edge of the cut line? Before you cut it up, you need to try, does it float in water? This is why you need the sink or the bowl of water. This activity is going to take you quite a few minutes. Hopefully it will be quite interesting. And the floating, of course, will link in with what we learned about density when we had the marine engineering workshops and we made our model boats. Think back to that. Right, obviously you can pause the video here while you're drawing the table and doing the activity. Here are the different symbols and the names that go with them. So your symbol is it's like a triangle, but it's made with arrows, so it's a triangle or a cycle joined together, so it shows that something can be recycled. And they've got numbers 1, 2, 3, 4, 5, 6. The names of them are right on the right hand side here. So number 1 is polyethylene terephthalate. Number 2 is just ordinary polyethylene. Number 3 is polyvinyl chloride. That's sometimes shortened to PVC, fairly obviously why. Number 4, polyethylene on its own, sometimes just called polyethylene, or sometimes just called polythene. So you will probably have heard of that. Number 5, polypropylene. These are all quite similar. Poly at the beginning, P-O-L-Y, 1 L, not 2, so it's not a parrot, it means many. Yeah. And number 6, general purpose polystyrene. And it does actually give you some examples of where it's used in the first column. I think this is actually quite interesting, but then I'm a scientist, so I would. Once you have used that information to fill in the second column of your table, we are going to have a sorting activity, and you can actually check how the groups 1, 2, 3, 4, 5, 6 before will actually sort. So if you haven't used the sorting activity before, I'll talk you through it. We always start at the top box. Hopefully you can see my little cursor moving around that. So each of these boxes is a question which has a yes or no answer, and depending what the answer is, shows the route that you go down your sorting tree. So does it sink when you put it in water? If the answer is yes, then it will be number 5, UPVC. That is the only plastic that will sink. All the others are no, so they would go to the right. When you've done that, you need to check, is the plastic flexible when you bend it? Yeah, so that means it will bend without resisting. If it is flexible when you bend it, then it's LDPE, low density polyethylene. That's used for carrier bags. Yeah, that would make sense. We know that they are flexible. No. If it's a no, then you carry on down the sorting tree. Does it make white marks when it is cut? Yes, then it is polypropylene, such as margarine tubs. No, then it's high density polyethylene, HDPE for short, used for shampoo bottles. Now, if you go on the website for recycling in Suffolk, you will be able to find which of these different types of plastic are accepted for recycling near you. Each council has slightly different rules on this, and it depends on who they have willing to buy the plastics to process them after they've collected them. Now, as they say in the advertisements, for the science bits. When you make plastics, we always start off with something called a monomer. Mono means one. So you have a very simple molecule. You can start off with ethene, which has got 2 carbons in the middle and 1, 2, 3, 4 hydrogens around the outside. And you'll see there's a double line between the carbons, which means it's got a strong double bond. Or you could start with a propene molecule, and that's very similar, except that one of the hydrogens has been replaced with a CH3 molecule, so it's a bit more complicated. When you join these together, lots and lots of them, you break the double bond in the middle of the carbons, and then you can join more molecules together, more identical molecules, and the N here shows you how many. So if you have 3 instead of an N, you'd have this 2 carbon 4 hydrogen molecule repeated 3 times. You could have N could be 10, N could be 100, depending how many molecules you've got to join together, how much energy you've got to put into it. Same with polypropene, and the brackets around the outside shows you the starting molecule, N shows you how many. And it's a little bit like having Lego bricks. So if you're building a wall of Lego, it's all red bricks. This is your red brick, and this is you joining lots and lots of red bricks together, as you've got down here. Slightly different propene, so instead of a red brick, it might be a blue brick, a green brick. Other Lego bricks are available, year 7. And you join lots of them together in a wall, but it is the same type of brick, so lots of the same monomer joined together to make a polymer. Now this makes some very strong molecules that we know can last a long time. The question is, how long? So I've given you a challenge here. You've got 8 items. You haven't been given picture cards. I'm not posting things out to all of you. And you have to decide which one will decompose the fastest, which one will be the slowest. You don't have to draw these out unless you want to. You can just do it, put the words in your books or have a think. See who agrees. You might be surprised. Pause the video here while you do it. And here is the answer. Now, fastest one to decompose should be a tea bag. I say should because most tea bags are made of paper and they will decompose quickly. However, recently some tea bags have started being made with bits of plastic in them. And guess what? Yes, that will slow down the rate of decomposition. A banana skin will actually decompose slightly faster than an apple. That's a bit of a surprise. Then you get socks, providing that they're made of wool. That's a natural fabric. It will decompose quickly. Paper will decompose quickly, although if it's got ink or it's glossy, it will take a bit longer. Then you get a plastic bag. Then you get a plastic bottle. Then you get a calculator. Now, how long do you think it would take for a calculator if you dumped it in the ground or put it into landfill because it wasn't working anymore, it wasn't recycled? How long do you think that calculator would take to decompose? Well, here's the numbers. Be ready to be scared. Okay, basic tea bag, 1 month. Banana skin, 6 weeks. Apple core, 2 months, around about 8 or 9 weeks. These are all things you might have put in the composter modules we made a few weeks ago. And if you did and you've still got those on the go, you should be starting to see some decomposition occurring now. Woolen socks, 1 year. Obviously, if the socks are synthetic, that means they've got plastics, they've got some of those long polymers we've just looked at, they will take a lot longer. A plastic bag, 1 plastic bag, 20 years. Double the amount of time that you have been alive. Scary, that. Magazines, 50 years, 50, because of the ink, because of the glossy paper. That is actually sort of like a little plastic cover on the outside. 1 plastic bottle, 450 years. I'll say that again, 450 years. See a bit of a problem here? Imagine how long it takes to decompose. Imagine how much space you've got. A mobile phone or a calculator, 1,000 years to decompose. Now you can see why we might have a bit of a problem with plastic. Very useful, but... So, here is the life story of one of those plastic bottles. Remember, they take 450 years to decompose. So, you have got a plastic bottle. It is made from raw materials. They have to be extracted. So you've got coal and oil to make the plastic. You've got a picture of a tree here to providing the fuel to actually provide the heat for the reaction that makes the plastic. Then it has to be transported to a factory where the raw plastic pellets are made into a bottle. Then it has to be transported to somewhere where it's going to be packaged. It might have water, it might have Coca-Cola, it might have squash. Other drinks are available, too boring to list them all. Then it will have to be distributed. Each time we've got a lorry, remember we've got the cost of the lorry, we've got the fumes it's putting out into the atmosphere, and then it gets used. And somebody has a drink. Then it gets dumped. And then it needs to be recycled, if it can be recycled, and then it will go round and round again. And this cycle, sorry about that, allows engineers or scientists to think about the actual real cost of the bottle. It's not how much it costs you when you buy it, it's the cost to the environment. So we've got a bit of a problem here. This has got a lot of cost making this bottle, and if it's dumped after being used once, it takes 450 years to go away. So here is a big question for you. How many plastic bottles do you think are thrown away every day? You can think about your home. You can think about how many that could be in the whole of Haverhill, whole of Suffolk, whole of the UK, whole of the world. Have a go at the numbers. This one you can probably count by having a look at your recycling, thinking how many you buy. This one is going to be a much bigger number. You might want to pause it while you do this and be prepared to be shocked. Here we go. Now, obviously I haven't got the answers for your home. I'm not coming to spy on anyone. What I could find the answer for was worldwide. This was shocking. In September 2019, so that's when we started year 7, September last year, they were believed there was 1.5 billion, that's billion, not million, plastic bottles in a day, which is 1 million a minute. Now, maths tip, a million has got 6 zeros, so that's the number in 1 minute. That's quite scary. And all of those, if they don't get reused, are going to take 450 years each to decompose. And these are the ones that are thrown away, not how many are remade. That's the number thrown away. Now here we've got a message from Sir David Attenborough. This is a very well-known clip from Blue Planet. I have put it separately in your email in case you have problems accessing it from this video. There is also a new program coming out on Netflix, if you have Netflix, from Sir David Attenborough. Not sure when it's available, but you may want to watch out for that if this sort of thing interests you. Now, we know that we are reducing single-use plastic at school, but there's still a lot of plastic in the world which will not decompose. So could we reuse it? And here's an example for you. This is a group in Nepal. Nepal is up in the Himalayas. It's near to Mount Everest, the tallest mountain in the world. There's a group of women there that are making crafts from waste plastic. So they get plastic sacks. These would have corn or maize or something in. They cut them into strips. They start to weave them and make them into things like pencil cases, things like rugs, which actually want to last a long time. I'm very fortunate. My brother went on to holiday in India last year, and he actually brought me back a big shopping bag that is made from plastic that has been recycled. And that was also from sacks that had had corn in, brightly coloured and woven. It's beautiful. If we get back together at school, I will show it to you. Now, you also have plastic waste that's available to use. You know already which types will cut. You know already which types you can bend because we did the practical. And I want you to think about what you could make that will actually reuse plastic so that it will stop it going into the waste. It takes a lot of energy to recycle it. Now, you'll need to make sure the plastic is clean and it really is waste. Do please check with your carers because they may already have a plan for that plastic bottle you think is waste. You may find some inspiration online. I know that people have made things like bird feeders in the past. You can send photos, you can send a presentation, you can send a video. You might want to send some instructions on how to make it so that if it looks really good, your friends or me can have a go ourselves. Remember to be sensible and safe. Take care with scissors, take care with glue. Ask permission before you heat anything. Plastics can give off gases which can be dangerous, so probably better not to heat them. Check with an adult before you do it, because what you think is waste, they may already have a plan for it. Now, this will also tie in with last week having been Earth Day. As I said, this is an opportunity to be really creative and to get lots and lots of extra R points. The best ones will get R3s or R4s. And if we can actually you can use what you make and save a little bit of plastic going to ground fill. This is great. You'll probably notice this lesson is tying in a lot of our previous lessons. Now, a little bit of new information for you now on Teams. Now, your information, the links for the PowerPoint will be available from Go for Schools and your class email. Details of your Senator task will go on to Go for Schools. That will happen on Wednesday. The previous task is due on the 29th of April, so the next one will start then. This task will also be added to Teams. Bear with me, it may take me a little while because it's the first time I'm doing it. You will already have had an email about Teams. Contact me if you need any help, but please, 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 if you're going to message me on Teams, do use our class page. I have got 8 classes, and if all those lovely students decide to message me on the main message bit, it's going to take me a long time to find the right place to put the answer. So, lots to do there, long video. Thank you for bearing with me. I hope you have fun. I hope you remember to stay safe, remember to get permission, but I really look forward to seeing what you create. And just to remind you, here are your objectives again. Sort and classify plastics by their properties, understand the impact of plastics on the environment, devise a reuse idea for plastics, and email a picture, a video or presentation of your item to me, your lovely teacher. And also, yeah, that's it. Sorry, I think I'm also tall. Take care, stay safe, enjoy the sunshine. Hope to see you soon.